Okay, so today we're going to talk about the SO8's addressing modes for various instructions, and I'm going to focus today on just this add without carry command, ADD. We're currently talking about page 96 in the manual, and also that these addressing modes have their own section on page 91 where there's a short explanation of each. This video should hopefully serve as an intro to that, and then you should be able to read that as a supplement. Okay, so before we get too far into the implementation details, I just want to talk on a top level what sort of things we want to do. So we want to do things that look like this, right? X is equal to x plus 5, or x is equal to x plus y, right? So different sorts of addition that you'd be very comfortable with in a C environment that we want to then understand how to implement on an assembly level. Another sort of thing we might expect to be able to do is, for example, if z is an array, so we have int z5, right, something like this, then we want to be able to say x is equal to x plus z2, right? We'll get into that in a little bit. So broadly speaking, these are the sorts of things that I hope you're still familiar with and comfortable with from C that we're going to try to look into and implement today. Coming back then to this add without carry command, if we want to think about doing something like x is equal to x plus 5, right, where this is some constant, this is something that we know in advance at the time we write the program, we know it's always going to be 5. That is perhaps the easiest thing to understand, right? So that uses what's called this immediate addressing mode, which is to say that the 5, this thing that we're adding over here, that's actually just wrapped right into the command. The opcode AB tells the processor, hey, I want you to add something, and then it also says that that something is going to come immediately after AB. So the very next byte is what I want you to add. Now, in general, since addition is a math operation, we're talking about doing something to the accumulator. So this isn't quite x is equal to x plus 5. It's the value in the accumulator is equal to the value in the accumulator plus 5. So something like this, 0x01 plus 5 is equal to 0x06, and then that's back in the accumulator. So the way that this is implemented in terms of the command language is going to be an AB followed by a 0.5, where these are hex values, right? This is an operation code, and then this thing here is what would be called an operand, or a thing that modifies the operation. In this case, AB says, hey, I want you to add something in the accumulator, and the very next byte is going to be that thing that I want you to add in numerical value. The next byte in this case is 5. That's going to make the accumulator value go up by a value of 5. Okay, but that only covers this first case here, where we're talking about adding a constant value that's known at the time that you write the code. There's certainly cases where you might do that, but there's also cases where you might want to treat something as a variable and have a different sort of value. So let's talk about how we might do something like this. Now the first note is that y as a variable, right? What is that? Just fundamentally, what is that? It's a space in memory. It's a place out in memory that you can go to and you can look up what y is. And if you write to that spot in memory, then you change the value of y. So the way that we're going to refer to this in assembly is we're going to refer to it by its address. So let's say for a second that we're going to refer to it by the address 0x100, where there's an understood 0 here. It's 0100. That's a location in RAM. It's a place where a variable that you declare might live. So then in this situation, we know we've got a value in the accumulator, and we want to add something rather than adding 5 here like we did last time. We're not going to add 5. We're going to add whatever's at y, whatever this thing is, whatever's at 0x0100. So how do we tell the compiler now to go check that? How do we tell it to go look? The easiest way to do that is in this so-called extended addressing mode over here. So in this mode, you give the entire memory address, that is the 16 bits that tell it where in memory that variable is located. So if you look at this command here, you'd see that the command, rather than being AB05, we'd tell it CB HHLL, where the HH and LL, in this particular case, would be 0100. 0, 0. So this is, again, the operation here, and then these 2 bytes are the operand, and those are interpreted as the most significant and the least significant byte of the address. Now, it's worth mentioning that those variables don't have to be things living in RAM. They could be registers, right? You could be adding in whatever's at port B, for example. Port BD happens to be 0x0002, so it's the 3rd byte in memory. And the designers have allowed us a slightly nicer way of accessing those direct page registers and the first few bytes of RAM, and that's because all of those are going to start with 0, 0. Rather than write out the full address, they've given you the ability to write just the last byte. So obviously this only works for addresses that start with 0, 0, but it does allow us to save a little bit of space and time. So that's the so-called direct addressing mode. You might notice that direct addressing mode bears a certain resemblance to direct page registers, right? Because the whole reason of that naming is that you can access them directly in memory without having to write out the full qualified address. Now, how would that look if we wanted to access that? We can't access 0100 because that is a 16-bit address. There's no way to get at it with just 1. But if I want to get port BD and add that to the accumulator, then it would just look like this, where this is BB, this is the operation that we're going to do. We're going to add to the accumulator in direct mode, and then the O2 tells it to go to that port BD location. Okay, so we've done pretty well for ourselves at this point. We've gained the ability to add in things like x is equal to x plus 5. We learned that that was the immediate addressing mode. This is a number that we knew at the time we wrote the program we wanted to add in. Then we've also gained the ability to do this sort of thing, where we add in a variable that we have a known address of. And I'm going to note that also, if we know something of this style, that would work too. Either of these two could be done using the extended, or if it's under 100, if it's 0x00 something, then we could use the direct addressing mode. But one thing that we haven't been able to do, or don't yet have the tools to do, is something of this form, where we say x is equal to x plus z I. Instead of z1, z2, z0, we're saying we've got an index variable I. Maybe it's something we read from an analog to digital converter. Maybe it's something we read from a switch bank. We want to be able to access a variable element of the array z. In that case, we can't use any of these modes because we don't know which one we're going to do at the time that we write the program. For that, we're going to need other addressing modes, and I'm going to discuss those in a different video. The other thing we haven't talked about is we haven't talked about how to actually go about programming these in assembly. But that's not too bad. If we look here at this left column, you'll see that it has assembly commands written for you. So ADD, then some space to make sure that you're in an operand, and then you have your choice of operands. And your choice of operand dictates which addressing mode you're in, and then that dictates which object code the assembler will put in for you. You don't actually have to worry about this necessarily. This tells you how many bytes it is, it tells you how many cycles it is, but you as a programmer know, am I adding in a value that I know right now? Am I adding in that 5 we've been using? Or am I adding in a variable that has an address? And the way that I denote that I have a number 5 is I just put a little number sign in here. So I'm saying add the number 5. If I don't put a number sign in, if I put in literally anything else, it's going to assume that that is a memory address. The variable name it could be, or it could be a hex or decimal number, which is the actual address I'm going to use. what typically suggests using a variable name or at least a defined constant such as port BD. Either way, the choice between the 16 and the 8 is also done by the assembler for you. It will always choose 8 if it can, which is to say that if you put in a value that's 16 bits, but it's below 00FF, then it will just choose direct mode as it should. Direct mode takes less space. You can see that instead of 3 bytes, it's only 2 bytes. And it's also faster. You can see that instead of 4 cycles, it's 3. So there's actually no reason ever to use extended mode over direct, except that you can only access those first 256 locations in memory.